These are the notes for section 4.4 on the laws of logs. And what we're going to do today is discuss the laws kind of briefly up front, then of course use them. Whether you call it properties like we did in 4.3, you call it laws in 4.4, they're all just rules. And they relate to things that are exponential, so we'll do that again like we did in the previous section. We talked about how the properties are related to their exponential counterparts, and we can do that again here with the laws. But ultimately, we're laying foundation so we can go on to do the more complicated stuff, which is solving in the word problems. Then the properties and laws, just we can drop in and use them whenever we need to, and it just makes, obviously, everything go a lot more smoothly. So let's get into the laws. Let's talk about the properties for review for a second. So anyway, I'm not even going to rediscuss it with you guys, but they're there. They may pop up as we do some of our other work today. So just kind of recall some of the rules, some of the basic rules, and especially the first three, and especially more so than any of them, probably number 3. Anyway, there they are, snapshot. Going to move on to the laws. So the laws, there are 3 of them, and basically it has to do with transitioning from blue to black. And if you guys look at it for just a second and think about what's the exponential connection, I don't think it takes very long, especially in numbers 1 and 2, to figure out where the connection is. If you look at the blue side and it's A times B multiplication, the black side is addition. Well, if you guys think about it, addition is multiplication when we're using the rules of exponents, right? Like I multiply the same base, I add the exponents. Number 2, I divide the same base, I subtract the exponents. Number 3 is maybe not as obvious, but it's actually a power to a power. So I'll show you all these in a second as far as like a little mini proof and how they kind of work out. We'll prove that they're true. You won't have to reproduce any proofs, but I think it's good to actually do this every once in a while, kind of derive the properties, the laws, the formulas, wherever they come from. The kind of proof we're going to do with you guys is a logic proof. And basically what we're going to do is a little bit of rewriting and use some properties and rules and mix them together a little bit and show you that, yeah, this is really true. Now, this kind of proof, again, nothing you got to reproduce, but we're going to try to prove this statement by using other things we know are already true. So we're going to start with the colors. We're going to do the rewrite with colors. We're going to go red to the black equals green. So I'm going from a logarithmic equation to an exponential equation. So red to the black, base to the exponent equals number. And all we really want to do now is, once the rewrite happens, is try to show that this expression can become this, and we've proven it. And what we're trying to actually do is give you guys the connection to the law and the rule of exponents, which you notice we're going to start to use to get there. What I have here actually is this side of the property. So this is multiply the same base, add the exponents. Here I have the exponents added, so we're going to pull it apart into this. So let's pull it apart. So when I multiply the same base, base A, multiply, I add the exponents. Well, since we started there, we're actually going the other direction. And then I've got a rule, a property from 4.3 that says that this expression can actually be replaced with, so A to the log A of x equals x. In our case, A to the log A of capital A is equal to A. And A to the log A of capital B is equal to B. And now what I've shown is that A times B equals A times B. By showing this side can become this side, we're proving the law is true. But actually my intention was not so much to do that, but show you guys the connection to the exponential equivalent idea. And then let's try the same thing with the subtraction part. So again, do the rewrite. We'll go red to the black equals green. We have this side of the exponential rule, so we're going to undo it. We're going to go kind of backwards with the rule. So subtraction is division if I go backwards. So in other words, if I'm dividing the same base, I subtract the exponents. And then if I use my property from the previous day, A to the log A of capital A is A, and A to the log A of capital B is B, so A over B equals A over B. And again, more about connecting the idea to the exponential than it is about you guys reproducing a proof, but again, good to see that. And then one more round quick, and we'll move on to some actual numbers and get these babies going with some good hard applications. But here's the rewrite again, so red to the black equals green. What I'm going to do is reshuffle the exponents, so I'm going to put the C to the back because I can, because it's multiplication. Here comes your power to power property, which says when you have an exponent raised to another exponent, you multiply them together. Well, actually I already have that, so we're going to undo it and go backwards and split them apart. So a power to a power is multiplication. And then using our property from the previous day, A to the log A of capital A is A, so A to the C is equal to A to the C. Again, it's not so much about you guys doing the proof as it is about the connection of the law to its exponential counterpart. Okay, let's get into the problems themselves. You guys will probably like this day. I think the stuff's a little bit quicker and easier, a little less to go through. One video should do the job. So there's kind of two ways you go with laws. You're either condensing the expression or you're expanding it out. Whichever way you're going, it's just practice. Which law are you using? How does it work? So we're going to the condensing part of this. So again, as I look at this, I want to sort of scan through my list and go, which one am I applying? Clearly, it's the addition. So addition goes down to multiplication. And then hopefully today you guys can look at this and say, I already know what the answer to that question is. And really what I want you guys to try to do is to be able to look at this, nothing on paper, just this alone, and say, yeah, the answer is. I didn't show you or do any work. I think if you can get here and go, yeah, I can go to 2 now pretty easily. If you got to go one more step, you can do that. But then at this point, you're done rewriting and rethinking the problem. We should be able to just see, hey, there's a property from yesterday. So log base a of a to the x equals x. But I want you guys to try to, from here, just go, it's 2. Because you can go 144, you can go 12 to the second, and this does not need to be on paper. Okay. Similar problem here where we're going subtraction. So we did addition to multiplication, now we're going subtraction to division. So 160 divided by 5 is 32. Again, I'm hoping that right from here you can just go answer. If you need the additional step of the rewrite, but you want to try to cut some of this stuff out because, again, more efficient, right? But 160 divided by 5, 32, log base 2 of 32 is 5. And this does not need to be written down on paper. So again, we're just kind of cruising through the laws here, showing you how each one of them can work in a different scenario. The last one, what the third law really allows you to do is just take your exponent up here, the c, and drop it down out in front. And that allows you just to work on this. So this 33 can basically be plopped down out front. And then can you look at log base 2 of 8 and just say that I know that's 3? Which you guys should. So I mean, there's this step of rewriting this part I'd like you guys to not do. Just try to stop. I'm just showing you so like you got it here in the notes, but you should be able to go, yeah, log base 2 of 8 is 3, and 3 times 33. My answer is 99. There is an alternative to this, which is from the original problem. So it kind of would be back up to starting right here. You just rewrite the 8 right away. So 8 is 2 to the third, and then third to the 33rd is the 99th as an exponent. And then you got right at the end of what I got there. Yeah, and then you got the same idea. So that'd be equal to 99. Okay, so a quick condense, and then it's in your head, working the logs, right? All right, then here's a string, and this is kind of a little bit about how you want to do the order of the problem. You do got a series of subtractions. I think the order that it sits in would not, to me, be the easiest, because you'd want to be going 100 divided by 18 or 18 divided by 50, and neither one of those is very nice to work with. So I think if you just redesign the problem and kind of shuffle a little bit, so let's just take the pieces of the puzzle here and move them around, which I totally can do. It's just a series of subtractions. Now this pair is division, so 100 divided by 50 is 2. And now I'm going to go, another subtraction is another division, 2 divided by 18, which is 1/9. Then I'm going to try to create a like base situation, so let's do a little bit of cleanup here. So there's my 1/9. And then 9 as base 3 would be 3 squared, and then power to power, and then my final answer, which is hiding out here somewhere. Well, which is -2, wherever I put it. Okay. So anyway, the answer to that one would be -2, and I've created, now if you can go back as far as maybe here, and try not to have this or this on paper, but if you got to do a few more, that's fine. Anyway, again, just more manipulating the laws to help you condense the problem. Okay, let's do expansion. So expansion is really just practice. It's not so much about getting a number answer, it's just about can you do it, right? So expansion means break it apart. So as you expand, you want to look through these different expressions and try to find one of 3 things, or all of them, or a pair of them, or whatever. But is there a multiplication, is there a division, or is there an exponent? So clearly right in here, I see a multiplication. So there's my expansion. Log base 3 of 5 plus, if I was to put this back together, addition would become multiplication. Here I've got a multiplication right there, but also an exponent. Law 3 says drop that exponent down out front, and then expand this with addition. You want to make sure you did a parenthesis, or else put 10 on both, because the expression, x and y, are both raised to the 10th, so you got to make sure you catch that. Here's ln, but ln doesn't change the rules at all, right? You can use laws and properties all with natural log. So multiplication right there, division right there, multiplication, addition, division, subtraction. And that's really all there is to it. When you have an exponent, again, it drops down. Now these are 2 separate expressions with 2 different exponents. That's why I've got them broken apart. So 3 out front, log base 2 of x, square root is a 1/2 exponent. Log base 2 of, and that's actually an error right there. Let me write over that quick. And I did a really sweet job of writing, but you guys get the idea there. That should be the expression x plus 2. Okay, like I said, nothing too complicated about expansion. It's more just like practice spotting the multiplication, division, and exponents in the problem. And then, you can make this as big a mess as you want. Again, it's just search for everything. So exponent 2 comes down. No exponent here, so there's just the expression. Exponent 1/2 comes down. Subtraction is division. Multiplication is addition. All right, let's move on. Back to some more condensing. So this is, again, just going to cycle back around. Sometimes you won't get a number answer that you could do in your head anyway. But that 2, when you condense, that 2 has to go up. So it looks like this. So now I got 5 times 36. Log base 2 of 180. 2 to the what is 180. That's not a whole number. It's not a fraction that's going to hit me in my head that I'm going to come up with in my head. So you're looking at going to your calculator for that one. And then you get things like this where there just isn't really any number. It's just an expression, right? So if I can find it here. So 2 goes up, 5 goes up, and then addition is multiplication. This one I would like you guys to try to do is pause the video for a sec and see if you can give me a number answer with no work on paper. Try to come up with one in your head. And then start it back up and see if you've got it. I'm going to track through it here in just a second. So a couple things I can do. I could take care of these right away. Log base 2 of 16 is 4. And log base 2 of 32 is 5, So if I think about it like that, at the same time, I could bring these exponents back up. So third law, logs would help me out. And then log base 2 of 2 to the 4th times 3/4 would make that exponent become a 3. And then times the 1/5 would make that exponent become a 1, which means you'd have log base 2 of 2 to the 3rd, log base 2 of 2, 3 minus 1. So the answer is 2. An alternative to this is you could actually say, hey, that's 4, and that's 5, and then go 3/4 times 4 and 1/5 times 5, and same spot, right? Okay, so, condensing, expanding, again, however you want to look at it, it's just all practice with the laws, and it's going to be able to manipulate and do these kind of problems. Last thing before I wrap it up is change of base. This is kind of a sort of an throwback because you guys have calculators that do this stuff, so we just want you to know how to do it without a calculator. So calculators prior to the advance of graphing calculators that were programmed to do all this great stuff were programmed for base 10. So when you put in LOG and hit the LOG key and then a number, it was doing base 10. But not everything is base 10. We can be in base whatever. So there's a rewrite. You can take any log expression of any base and rewrite it as log of the number over log of the base, and that's how you want to do it. So log of the number over log of the base. You still got to go to your calculator. So here's the thing about doing this in your calculator. If you type in log 7 divided by log 3, which I'm just going to do quick, there's your answer. Or in your math menu, you got to scroll to the bottom. There's a log base key, or you can do math alpha math, which would be kind of a quick shortcut to having to do the scrolling part of it. And then it allows you to type numbers in, so now I can go back and look at my expression and just put it in. That's great. So the calculator does it for you, so I can put in the 3 and the 7 and get the same answer. What I'll tell you is you might just be putting this in faster than you would by going into your menu, or maybe not, whatever. We don't really care. If you want to use the key, but we may ask you to at least reproduce this idea. Okay, that's going to wrap it up for our 4-4 notes.